Hi guys, welcome back and welcome to my YouTube channel Electronic and CNC Lab. In today's video we will see how it is done and how to use the 16x2 character dot matrix alphanumeric LCD display. Let's start by saying that most of the displays in this family use a chip produced by Hitachi, the HD44780, which is able to control LCD displays capable of displaying only characters. These displays come complete with controller and range in size from 8x1 characters consisting of a line of 8 characters up to larger sizes including 8x2, 16x2, 20x2, 16x4, 20x4 characters and more. Due to its popularity, the HD44780 controller is now considered a de facto standard for LCD display control. In fact, it is used above all in the embedded field for the realization of displays of hobby electronic devices due to the wide versatility, ease of interfacing and low cost. Now let's see the external dimensions of this display. So, on the left we have the structure of the single digit of the display, which is formed by 5 pixels wide by 8 pixels high, and instead on the right we find in the graphic representation the display with the 16 connections at the top with pins from 1 to 16, from left to right, and then the 32 characters arranged on 2 lines of 16. But let's now move on to the function of the 16 pins of this component. Well, the first pin is the ground pin. The second pin, VCC, is typically connected to a 5-volt supply. Then there's the third pin, VEE, which is for contrast control. The fourth pin, on the other hand, is called RS, where the value 0 is selected for sending a command and instead the value 1 for sending data. Then we have pin 5, RW, read and write, where 0 is selected for writing data or commands and 1 for reading data or display status. Then we have E, enable, pin 6, which starts the write or read cycle. And then we have the 8 data bits from D0 to D7, which occupy pins from 7 to 14. The last 2 pins, however, 15 and 16, correspond to the anode and cathode of the LED diode for display backlighting. As I mentioned earlier, this display has 8 bits for parallel data and command transfer. The display of this family, however, supports both the 8-bit transfer mode, i.e. the integer command, and 4-bit or nibble. For example, if 8-bit transfer mode was selected, the 8-bit command will be sent in full. However, if 4-bit transfer mode has been selected, only pins DB7 to DB4 will be used and thus 2 transfers will be made. The first 4 bits of the data will be sent first and then the last 4. This last 4-bit transfer mode, instead of 8, is the most used, which allows you to save 4 bits on the controller that must drive it, which in our case it's an Arduino Uno. So, let's see immediately the summary diagram of the connections between the Arduino Uno and the 16x2 display. Let's start with nutrition. It can be supplied by a connector from an external power supply with a voltage between 7 and 12 volts, or the even more convenient and simple solution is to use the USB connection, which on one side goes to the computer and on the other supplies the 5 volts to the Arduino Uno. Furthermore, this connection also allows us to program the microcontroller. Now let's see how the various signals are interconnected between the Arduino Uno and the display. Let's start from the ground. Ground has the GND pin here, which is connected to 3 pins of the display. Pin 1, which is the display ground. Then we have pin 5, which is the RV, which connected to ground allows us to write on the display. And then we have pin 16, which is the display backlight cathode. Then we have the power supply positive, which is connected below, to the 5 volt. And on the display it reaches pin 2, which is the power pin of the display. And through a 220 ohm resistor, which is the series resistance to the backlight LED, it connects to the anode. Then we have pin 3 of the display, which is connected to the cursor of the 10k ohm trimmer. By adjusting this screw we can adjust the contrast of the display. We then have 2 lines, these here in orange, which are connected to RS and enable, which go to pins 8 and 9 respectively. And then we have the 4 bits, not all 8, because in our case we use the 4-bit transfer mode, which are the bits between DB4 and DB7. And they connect respectively to bits and pins 5, 4, 3 and 2 of the Arduino header. That is, they are digital pins. With this we have completed the interconnections. Let's now see in practice how they can be reproduced on a protoboard or breadboard. So, let's see the connections on the breadboard right away. First I brought both black, which is ground, and red, which is 5V, to both sides. Then I connected them to the ground line, which is an uninterrupted line of pins connected to each other, both on one side and on the other, which has the V3 line, which is then jumpered on the V4, and I did the same thing on the V1 and V2. So these 2 red lines both correspond to 5V for me. So I connected the 5V here to the 5V pin on the Arduino Uno, and then I brought the ground connections to pin 1, then to the 5V, which we see over here, and finally to the last pin, which is 16V. All of these jumpers connect to the ground of the Arduino board through this jumper here, which goes to the GND pin of the Arduino board. Then I connected the 2 ends of the 10K trimmer, which we have here, this trimmer. I connected them through this jumper and this one to 5V and to GND, and with the yellow cable I brought the cursor to pin 3. Here it is yellow. While on the connection diagram it was a blue cable. Then we have the 2 connections that go from pin 4 and pin 6, they go to pin 8 and pin 9. And we have them here. And then we have the 4 bits, which are from DB4 to DB7, which we have here, the 4 orange wires, which then go to connect to the digital pins of the Arduino Uno, 5, 4, 3 and 2. We then have the resistor behind it, which must be connected on one side to pin 15 of the display, a 220 ohm resistor, while on the other end it goes to the positive power supply. The last pin of the display, pin 16, goes directly to ground through this black jumper. At this point that we have made all the connections, we can move on to the creation of the sketch to test its operation. We then open the Arduino software. I have the most recent version that was in the distribution, the 1st of August 16. So, let's start right away with importing the library. Go under Sketch, include Library and import Liquid Crystal, liquidcrystal.h. Then let's insert the comment with the description of the parameters of the initialization function. We have 6 parameters, the only one is RS, the second is enable, and then we have the 4 bits, D4, DB4, then D5, D6 and D7. When I go to initialize the display, I will have to indicate the pins corresponding to the connections on the display, therefore pin 12 connected to RS, pin 11 to enable, pin 5 to DB4, 4 to DB5, 3 to DB6 and 2 to DB7. Now let's go to the actual code. We now go with the display type declaration, LCD begins 16.2 and it tells us that it has a 16 character by 2 line display. Now let's print a string with LCD print. That is printed by default on the first line of the display. Starting from the leftmost character, the one defined as the 00 character. With delay we make a small delay of 2000 milliseconds, therefore 2 seconds, before go to the next view. Now with LCD set cursor we are going to position the cursor on the second line, which is indicated as 1, the first line is 0, and the first character which is the 0 character of the second line. At this point we can print a second string. Starting from the leftmost character. Then add a new message, so to ensure that the writings do not follow one another too quickly, we set a 3-second delay, erase the display, LCD clear, which goes to position the cursor again on the first character of the first line, therefore the character 00. With LCD print we print a third string, here the quotation mark is missing. We put a new delay of 1.5 seconds. We are now going to position the cursor on the second line and display the fourth and last string. With LCD print. Let's now load the sketch or firmware. So first of all we check on tool if the Arduino UNO board is indicated correctly and then if we are connected to the right COM, in this case it is COM5. So we can check the code just inserted and then to upload it. If we haven't forgotten some punctuation marks and we haven't made any mistakes, the message done uploading will appear. Well, at this point I'd say we're done. If you liked the video remember to leave me a like and subscribe to my channel. But if you want to receive automatic alerts every time I upload a video, click on the bell too. Now goodbye and see you next time. Bye and enjoy yourself.